day to all of us, especially to you, Sir Ilian Roy Iscaro. I am Sahada B. Canapea, Bachelor of Secondary Education, major in Science 3. And today, I am discussing to you how to calculate the relationship between voltage, current, and resistance in a circuit. But before we are going to do that, let us define first what is Ohm's law. So what is Ohm's law? When we say Ohm's law, it's a formula used to calculate the relationship between voltage, current, and resistance in an electric circuit. To students of electronics, Ohm's law, that is equal to E is equal to IR, is as fundamentally important as Einstein relativity equation that is equal to E is equal to mc squared as to physicists. That is, E is equal to I times R. So, when we are going to spell it out, it means a voltage is equal to current times resistance, or volts is equal to amps times ohms, or V is equal to 8 times ohms, or the Greek letter omega. So, if two of these values are known, technicians can refigure Ohm's law to calculate the third. So, let us modify the following pyramids. Now, if you know or if we know the voltage and current and want to know the resistance, what we are going to do is to X out the right R in the pyramid and calculate the remaining equation. So, let's see in the illustration. So, we are going to X out the R, which is so we are going to cross out the R. So, the formula is equal to R is equal to E over I, or resistance is equal to voltage over current. Let's see the example. So, here in our example, or here in our illustration of lamp, we have the voltage and current. And what we are going to find is the resistance. So, we have the current of 6 amps and 24 voltage. So now, what is our resistance? So, we have here the formula. R is equal to E over I. Resistance is equal to voltage over current. That is equal to 24 voltage over 6 amps. So, we have 4. We have 4 resistance now. The second one is, now, if you know voltage and resistance and want to know current, X out the current and calculate the remaining 2 symbols. So, here's the formula. Let us X out the current. I is equal to voltage over resistance. Here's the example. Voltage and resistance are known. So, what is the current in the circuit? That is, current is equal to voltage over resistance. So, we have 12 voltage over 6 resistance. So, what is our current in the circuit now? That is equal to 2 amps. 12 divided by 6 is equal to 2. So, we have 2 amps. Now, and if you know the current, or if we know the current and resistance and want to know the voltage, multiply the bottom halves of the pyramid, or here in our illustration. Let's X the E. So, voltage is equal to current times resistance. Here's the example. Current and resistance are known. So, what is the voltage? So, we have the value of current that is equal to 5 ohms and resistance is equal to 8 ohms. So what is the voltage in the circuit? That is equal to, voltage is equal to current times resistance is equal to 5 ohms times 8 ohms is equal to 40 voltage. So the value of our voltage here is 40. So, that is the formula on how to calculate the resistance, current, and voltage in a circuit. So, when Ohm published his formula in 1827, his key finding was that the amount of electric current flowing through a conductor is directly proportional to the voltage imposed on it. In other words, 1 volt of pressure is required to push 1 amp of current through 1 ohm of resistance. So what to validate using Ohm's law? Ohm's law can be used to validate the static values of circuit components, current levels, voltage supplies, and voltage drops. If, for example, a test instrument detects a higher than normal current measurement, it could mean that resistance has decreased or that voltage has increased, causing a high voltage situation. This could indicate a supply or circuit issue. So, in direct current, circuits, a lower than normal current measurement could mean that the voltage has decreased or circuit resistance has increased. Possible causes for increased resistance are poor or lost connection, corrosion, and or damaged components. So, loads within a circuit draw on electric current. Loads can be any sort of component such as small electrical devices, computers, household appliances, or a large motor. That's end my discussion, and thank you so much for watching and listening.